Exercise 1107 is about applications of trig functions. Now these get asked a lot in HSC, particularly with things in terms of like tides, because tides are periodic, they go up and down. Could be something to do with seasons like weather, because anything where it's periodic, you're going to get these trig functions coming up. So in this example, we've got some population. At the beginning, there are 7,000 in the population, but it might be like rabbits or mice or something like that. At 7,000, there's not a lot of food because there are so many of them. There's not a lot of food, so the population starts to reduce. And a year later, the population is measured to be at 5,000. Another year later, they measure them and they've gone down to 3,000. But now, because there are so few of them, the food is starting to come back again. So they're going to start rising again, and they're going to be just a little over 5,000. And then a year later, they get measured again, and they're back up here near 7,000 again. Now, it doesn't follow an exact curve, but it's pretty close. So you could draw an estimated curve on there. Now, because it starts up high, it's at its maximum, we'd expect a cosine curve rather than a sine curve, and has its minimum down here. So as an approximate curve, this is what may have happened in this population. Now, I'm going to make it an exact cosine curve, so I'm going to go through this point rather than that point, because it's just a model to approximate what's going on in this population. So again, I'm going to go up to there. So there's a cosine curve that approximates the population over time. When the food starts to run out, the population starts to reduce, but when there's not much food, the population can thrive again. So we get this cosine curve. So we can see here the period is actually 4 years. And the amplitude, remember, from the center up is around about 2,000. The center is at 5,000. Now we can use that information to actually write an equation. Now this exercise doesn't actually ask you to write the equation, I believe, but I'm going to do it anyway because it does come up in the HSC. So because we're using a cosine curve as our model, we might start with population equals, and I'm going to write K cos NT for time in years, plus C. Notice there was no phase shift. Normally we'd have an A here, but I have used N. Now we know that the period is equal to 2 pi over this number, and I've used N again. So our N is going to be, if we times by N and divide by 4, it's going to be pi on 2. Our K is our amplitude, so 2,000 cos pi t on 2 plus the center, so plus 5,000. So there's our model, there's an equation for our function. Now in this exercise, you're literally just going to be reading numbers off the curve. So if they said to estimate the population after 2.5 years, there we go, right there, after 2.5 years, about 3,500. Okay, so that's just reading off a curve. That's quite easy to do. You'll be asked about period a lot, you'll be asked about amplitude a lot, and you'll be able to ask to read off the curve. So what's the population after 2.5 years? 3,500. After how long does the population first drop below 6,000? So it first drops below 6,000 about here. So because this is 1 year, if I divide it into 4 lots, each of these is 3 months. So I'm going to go with 9 months.